Good morning, everybody. I'm Dr. Navneet Kumar Pandey, working as an associate professor in Mechanical Engineering Department at JSS Academy of Technical Education, Noida. Let me begin with the next series, Design of Machine Elements. My previous videos have been associated with strength of materials and fundamentals of mechanical engineering that are taught in third year and first year respectively. This is the first time I'm entering into design of machine elements, and I hope that the videos will be equally helpful to you all students. Now, starting with fundamentals of machine design. What is machine design? What is the importance of machine design for engineers? How do we create and better machines and improve existing ones that are economical in cost, production and operation? Now coming to machine design is defined as the use of scientific principles, technical information and imagination. Whatever we have learnt as mechanical engineers in first year, second year and third year until the fifth semester, this course is taught as a full-fledged subject in sixth semester. So whatever we have learnt in first semesters, second, third, fourth as well as fifth, we try to apply all those principles in practice, and we arrive at the creation either of a new product, we try to improve the existing product, and as far as the course curriculum is concerned, we are given a sort of operating parameters, and depending upon the operating parameters, based upon the technical and scientific knowledge that we have accumulated over these 5 semesters, we try to put them into practice and come out with the standard specifications, or let us say dimensions, or let us say basic output variables in terms of elements of machine design. So if you look at machine elements, there are certain prerequisites or pre-desired characteristics that we are expected, or that we expect that the machine shall be having in it. One is strength and rigidity. Strength means how much stress the body can handle without failure. Rigidity means whether it buckles down due to a type of loading. Wear resistance provides you with the ability of a material to not go for abrasive, erosive or adhesive type of wear. The materials that we are designing should have minimum dimensions and weight, because dimensions and weight, they directly correspond to the cost of the material. So greater the dimensions, greater is the weight, greater is the cost of the material. Manufacturability means that we should not create a structure, we should not go for a cross section which is very difficult to manufacture, because at the end of the day it is the manufacturing department has to go for it, and he or she has to go and produce that component out of a basic set of input raw material. These input raw materials may vary depending upon the places, depending upon the requirements. So it is very necessary that whatever we give as an output to the manufacturing department, it should be to the best of the ability and it should be very easily manufactured. Next comes the safety. Safety means that where the component is to be used. The same component, if it is used in a bicycle, we will have different safety standards as compared to when it is used in an aeroplane or in a ship, because greater the risk involved in it, greater is the safety parameters to which the product has to conform. Conformance to standards means that the product, whatever we are manufacturing, if there is a standard specification as mentioned by various standards bodies like ISI, DIN, and foreign SAE, these all standard institutes have recommended a preset requisite standard in terms of quality, in terms of dimensions, in terms of application, and it is very necessary that once a product is being designed or brought into the market, it should conform to the standards. The basic purpose of standardization means to avoid monopoly of a product in a market. Reliability confirms to the life cycle analysis of a product. Greater the reliability, we can say that greater it will be useful or greater we can rely upon while making it work. Maintainability, a product has to be, once it is launched or once it is fitted into a system, this system has to be maintained and every product becomes a part of it. So it has to be easily maintained because the maintenance process should not be such cumbersome that it becomes very difficult to accommodate that product. And the next one is minimum life cycle cost. Minimum life cycle cost means that the life cycle product of the body or the component that we have designed, it should involve lesser number of cost parameters while relating it to its overall maintenance. Now, coming to the materials and their properties, the materials that we use or that we take them as a basic purpose for design, there are certain best suited characteristics that we desire. One is availability. We should not go into a product that is scarcely available or not readily available in the market. The material also depends on the mechanical properties. Mechanical properties are of two types. One is what is justified and then next one is what is available. So you can have n number of mechanical properties that you require, but you have to also see what all is available in the market. Manufacturing conditions, you cannot choose a material which has a very difficult method or very difficult process of getting it manufactured or getting it machined on different surfaces. Coming to mechanical properties, you have toughness, malleability, ductility, brittleness, hardness. These all properties you must have come across in your other subjects, so they are just a mention for you. Now coming to the general procedure in machine design. Now let us see what is the general procedure in machine design. The general procedure says that we need to have an aim or there should be a need depending upon which we decide what to design. So before designing any component or a product, it has to be associated with a need. So synthesis means it is the evaluation or estimation of the net balanced and unbalanced force acting on it. We need to see what are the active forces on it and what are the reactive forces acting on the component that is supposed to be designed. It also includes the study of mechanisms involved in it. Now, analysis of forces means that what are the different forces that are acting on the body, how will they be concerned with the problem, what are their effects, what are the factor of safety, what is the utility of the product, and what is the quality control that is expected out of it. Now, coming to the next point, that is material selection. In material selection, we decide what is the most suitable material for the fabrication of the product. So let us say if you are going for gears, you have a choice between steel, you have mild steel, copper, bronze, depending upon the application of the product. Whereas if you are going for pulleys, we go for mild steel or high grade steel as an option. So if you go for belts as an option, generally nylon or elastic members are used as members for design of belts. So likewise, material selection plays an important role wherein, because the selection of the material also conforms to what are the expected stresses the material shall be able to withstand without failure. Next comes a design of elements. In design of elements, we see what are the various characteristics, what are the various governing mechanical relationships, what are the governing related physical relationships, what are the governing statistical relationships that will be a part of deciding the dimensions or the direction of the product in which it is to be designed. Next comes modification. After the design has been done, we need to see what all modifications may be required or it is expected that it will be required to draw or to fabricate the product. And last comes detailed drawing. In detailed drawing, we draw the complete structure, we draw all the views, projections of the component that is being designed according to either actual scale or based upon a modified scale. These drawings are a source of input to the production department, or you can say the manufacturing department. The production or the manufacturing department receives in return the drawing as well as the material that has been finalized in the process of design. Now the design considerations, these are the various factors based upon which we decide what are the features that need to be seen while designing a product. Strength means what is the stress that the body can withstand without failure. So strength forms a criteria for most of the design of the products. Rigidity means does it deflect under the action of load. So if you are designing a beam, probably you need to see that the material has to be rigid enough. Reliability, life cycle analysis, safety, conforms to quality. It also takes into account the location at which the part is expected to be used. Cost plays a very big role in deciding about the application or design of the product. Weight also plays an important role, because if you take the case of an airship or a marine ship, weight is a very important criteria, whereas if you take the case of a bicycle, probably it may not be that so important. Ergonomics means the man-machine relationship. So like for example, the man-machine relationship, in India we have a left hand, we are supposed to walk on the left hand side of the road, so we need to see that the steering is on the right hand side of the vehicle. This is a man-machine relationship. It enables us to control the road conditions in a better way. Similarly, in European countries you have a different system. It is exactly reciprocal of what we follow in India. If you come to another very big example of ergonomics, we see that the indicators, the vehicle indicators in the case of cars, are on the right hand side, whereas the left hand side handle, it corresponds on the steering, it corresponds to the wiper control. Now this is another example of man-machine relationship, because direction indicator is expected to be used more as compared to a wiper, because a wiper is only used in case of rain or when there is some dirt on the windscreen. So more the use, so it should be more handy as possible. So that is one reason why generally in most of the vehicles that are manufactured and sold in India, they follow this ergonomic principle. Similarly, aesthetics leads to beauty. It is well said that beauty lies in the eyes of the beholder. So a beauty feature may vary from person to person, but a designer of any component tries to make its own product as beautiful as possible, so that it becomes lucrative to the eye once it is being sought by the customer. Manufacturing conditions, a product, a cross section can only be decided, but it has to be some other way manufactured by somebody else. So we need to see that the manufacturing possibilities should be as easy, as cost effective as much as possible. So you should not select any intricate cross sections like I section, T section for the design of various products, because that makes the manufacturing very costly. Assembly considerations, generally a single part does not form a system. A system is a collection of different components which work in conjunction to justify a certain operation. So the assembly portion of every individual component in the design should be as handy as possible. Conformance to standards means that product should be as much standardized as possible. That makes it more reliable, that makes it more acceptable in the market. Any component that we are fabricating, manufacturing or designing, it should involve to the maximum as much as standard components. Friction and wear, depending upon a specific type of application, friction, wear, because generally the parts may have physical contact with another, that may lead to friction and wear between them. So the friction and wear characteristics should be good enough for any product. Similarly, life is reliability analysis. Vibrations, depending upon the application of the product. Suppose you are designing the bed of a lathe machine, it should be made up of a material like cast iron, so that it is able to withstand vibrations and it has good damping characteristics. Similarly, thermal considerations, uh, if the component is expected to be subjected to various thermal conditions like extreme heat or extreme cold, the material property should be selected such that it is well accepted at those locations as well. Lubrication, there are certain materials which are self-lubricated, there are some materials which need to be frequently lubricated, there are some materials depending upon the type of application need to be lubricated by semi-solid or solid lubricants. So all these factors have to be taken into account such that if let us say that you are using a ball, you are manufacturing a ball or you are designing a ball for a ball bearing application, that ball bearing will be subjected to semi-solid or solid lubricant. It will not be generally not be subjected to liquid lubricant. So we need to see the acceptability of those balls for semi-solid and solid lubricants. Next is maintenance. The maintenance of the product should be as less as possible. Flexibility. Flexibility gives you flexibility in design, flexibility in acceptance, flexibility in use. Size and shape, obviously the size and shape should be pleasing as well as acceptable to whatever conditions they are subjected to. Stiffness, again, it is related to the deformation under an applied load, it should be as less as possible. Corrosion conforms to a situation where it is reacting or it is oxidizing in the presence of oxygen and forming a rust. So a material should be such selected that it is subjected, if it is subjected to atmospheric oxygen or moisture in the air, it does not produce rust. Noise, generally metallic components when they come in physical contact with each other, they produce noise. So noise is one factor in selection of different materials. Nowadays environmental considerations are also of prime importance because they also need to be taken into account while we are designing a component. The manufacturing considerations in design, if we see the manufacturing considerations in design, we should have minimum number of parts in a product. There should be minimum variety. If we say minimum varieties, we should use as much standard parts as much as possible. We should use standard parts that gives the customer a variety of choices. Use modular design. Modular design conforms to those types of design parameters or those types of design sections which are readily available, which are readily acceptable and which are readily in practice. The parts that we are designing, if they are multifunctional in nature, it provides the user with more number of options. The design parts should be of multiple use. We should select least costly material. Obviously, if the cost of the material increases, the cost of the product increases as well. And the design parts should be easy to manufacture and the shapes should be such that it minimizes the number of operations that are required in manufacturing of the product. Now these are design considerations for castings. Castings are generally done with the help of cast iron like material and they are expected to have good damping properties. Likewise for forgings, we can have an account where forgings are being done so that forging materials are being produced so that they produce shapes of various shapes and sizes. Now similarly for welding, standardization. Standardization is a set process where we have a set of norms to which a specified set of characteristics of a component or a product should conform. Now, let me the objectives of standardization is to make the interchangeability of the components possible. Now, standardization means, let us say we are selling a vehicle, let us say a car. So, if we are selling an Alto car, the tire specifications are mentioned in the manual. It is not compulsory for the owner to get the tires replaced by the parent company. He has a variety of choices. All these companies, let us say Apollo, MRF, Seat, Michelin, Yokohama, they will be producing the tires of the set dimensions, and the user or the consumer has a good variety of choices depending upon the performance characteristics he requires. So that gives the consumer a variety of choices. Moreover, it becomes mass production of the components easier because you don't need to design a tire for an Alto vehicle. Once the specifications have been selected, the rim, the brake shoe pad on which it is mounted, everything is well defined, and you can only order from the market. And these established products, well established products, are sold to the parent company, and they can assemble it and sell it. Similarly, when we talk about the different products, all these different products provide us with different options, with different variations, and allow us to use them in whatsoever manner possible. A preferred series and its selection. Preferred series are generally a set of numbers that are obtained by geometric progression, and we have the series that gives us or the it gives us a choice of what all preferred zones or preferred magnitude of the components that should be manufactured, or what is the range of various commodities that should be manufactured. So these are certain mechanical properties, these are effect of alloying elements, and this is how we designate steels on the basis of mechanical properties. So preferred series will be taking up individually in our next lecture. Now if we see the designation of steels, you can see that, let us say for example we have Fe290. Fe290 means that the minimum tensile strength of the material, Fe corresponds to that it is a steel, and 290 corresponds to that it is having a minimum tensile strength of 290 Newton per mm square. Similarly, if we say 20C8, this is another way of representing. So it can be said that if we divide 20 by 100, we say that it is having 0.2% on an average carbon and 8.6 to 8% of manganese. So the left hand side of C denotes the percentage of carbon divided by 100, and the right hand side divided by 10 shows you the amount of manganese in the product. Similarly, we have different other ways of designation of low and medium carbon steels, where we have different multiplying factors, like you can see chromium, cobalt, nickel, manganese, silicon, and others. So again here, if it is written as 40 Cr4MO2, that means it is having 0.4% carbon, 1% chromium, because the multiplication factor is 4, so we divided by 4. So we have 1% chromium, we have 0.25% of molybdenum. So if you look at standard designation of high speed tool steel, there is CXT75W18CR4V1. It is tool steel with average carbon content 0.75, tungsten 18%, chromium 4%, and vanadium 1%. So we were talking about preferred numbers. Now all these designation of steels that we are seeing here, these are clearly mentioned along with the specifications in your design data handbook towards in appendix 1. If you go to appendix 1 in your design data handbook, you can see how steels have been designated and in which manner they have been designated. Similarly, if you see preferred numbers, so preferred numbers will be taking up individually in a next video, where we will see what are preferred numbers, how are they calculated, and what is their effect. Now coming to the strength of the component, the factor of safety is the strength of the component divided by the allowable stress in the component due to the actual load. So this gives you the factor of safety, and it depends upon the cost, the risk involved, the unknown stresses, the environmental conditions, the knowledge of environment, the properties of material used, the properties of tension, compression, shear, whatever it is, the weight factors. If we see for aerospace applications, we have different weight factors, whereas for bodies or systems which are running on road, we have different weight factors. So what we'll be seeing, what is to be done for preferred numbers in our forthcoming video. Thank you.